Hello, B.F.D followers. I'm back. It's a little slow going, but I hope you guys are hanging in there and you've had some success in building your jig and doing the main triangle and everything. And so I think where we left off, it's been so long, is that we were going to start working on our chain stays. Okay, and you can get your chain stays pre-bent, straight, different types, S-bend, single bend, and most of the time that will suffice, and sometimes you have to do some additional bending or crimping in order to get it to fit your requirements. So here's my chain stay, at least one side, and I just wanted to show you that I ended up doing some crushing common to where the chain ring is going to interfere with it, and that might happen because it's, in this case, it's a 29er that I'm building, and I'm designing for kind of a fat tire, not a real fat tire, probably 2.4 is the largest you'd want to do, but you could probably shoehorn a 2.5 in there. You might get a little rubbing, but it's 2.4. And so I thought, one, I'm going to show you how I do mine, and I also have a hack that might be useful for those that don't have a jig or a CAD program that they can print out their designs in full size. And so here we go. All right. First hack is I have a block of wood, pretty simple, right? And it is 2.5 inches in diameter or in width. Actually, it's a little bit more than that, 2.85 at the widest point, but at the tip where your tire would be is close to 2.6 about. So I use a block of wood as a test to slide in behind the bottom bracket and to see if my chainstay is going to ride or get or touch, ride was right, in there, right? And if I had any interference in those places, I knew I had to make an adjustment in order to make that have sufficient clearance. So if you're designing for a 2.5, you're going to want, at least 30 thousandths, 40 thousandths clearance on each side. That's not very much, but that would be the absolute minimum. I'd probably do 50 thousandths just to give you everyone an idea of what 50 thousandths would look like. It's not a lot. Sounds like a lot. That's a lot. That's all it is, right? So you'd be hard pressed to get any type of clearance when you had debris and junk, right? So I would say that I would do probably 300 thousandths on each side. So it'd be 600 thousandths would be a total width. That's what you'd be looking at. That's ideal, right? That way you'll have clearance. And this block of wood will help you do it. Now, the other thing that I've always had problems with is when you attach the dropouts, they have to be in an angle such that your tire will ride down the center of the chainstays. And if you weld your dropouts on incorrectly, and then you go and you then miter your your forward end of your chainstay made up to your bottom bracket, if you make any adjustments this way and your drops don't account for that, then your tire is going to move side to side, right? And if your chainstay is up or low, it's going to cause your wheels to do different things. And one, your bike won't ride that well, and two, it won't look very good. So we got to work on that. And I've always had problems with that, to be honest. And I don't know how many times I've had to cut I don't cut them off necessarily, but I will have to do a release on one side or the other of the dropouts in order for me to bend them. And once I get them bent correctly, then I'll weld them back on all the way. And that always works, but it's not efficient, and it's easy to make a mistake and cut into your chainstay itself, and then you got to replace the chainstay. And I've done that too. It's kind of a learning curve. I've been teaching myself. I've done research on the World Wide Web, internet, but it seems like that's one area that people don't share that information that freely, and so I've had a hard time. And I'm going to show you what I've done to help improve that process for me. Okay. So here we go. What I've done is I've taken my dummy axle that I put on the lathe and cut, and I took an old frame that I built and I cut it up. I chopped it. And the reason why I did that is because it was a good frame to use as a benchmark. And so I cut it apart, and now forgive me, the bottom bracket and chainring that I have on here is another test that I was doing with some painting and things like that. So it's Frankenstein, okay? I have to laugh because it is really ugly. It is green cranks that I was trying to do some powder coating with. But anyway, so dummy axle, and I cut the chainstay off of the bike, but I kept the bottom bracket. Then I mounted the bottom bracket and chainring in order to represent a true bike. Okay, and in this case, it really doesn't matter whether it was designed for a 27.5, 26-inch, or a 29er. What you're looking for is clearance down here. All right, your chainstay and everything will dictate what size wheel you're going to be putting on to some degree, and your design. All right, but this clearance area is what you're looking for. All right, so you could just chop an old bike. If you have a 29er, even better. You can chop the bike apart, and you have a template. And when I say template, of course, what I mean is you can take your chainstay. It's a little rusty. It's been sitting around for, 3 months now? Anyway, so what you can do is you can take your chainstay and you can nestle it in here, and you can kind of move it around and see how it fits. And if you hit your chain ring, you know that you got a clearance issue, right? So I got to move that back here to match up with the dropout. But then I'm hitting the chain ring, got massive clearance in there, right? So that's overkill. As a matter of fact, your crank arm might actually come back here and hit your chainstay. So good point there. You got to watch that too. The Q factor on your cranks can screw you up. So anyway, you can move your you can move your chainstay forward and backwards, in and out, until you match your template. Now, those of you that have like a CAD system, you can print out a trace of this design or any design that you have, then you can physically lay your parts down on the paper and know that it's what you need, and you can cut your parts right from that. And that's a very good way of doing it. If you have a CAD program and a system that a plotter, you can do it on little 8x11 sheets, but then you have to paste them all together, right? Done that too. But anyway, so what you can do is you can just sit there and move your parts back and forth. I have magnets that I can use that I hold in place, but just to give you an idea, this is what it would look like, sort of. And let's say I said, that's perfect. That's exactly what I want. That is, I've checked for edge margin here so I don't blow off the edge and start cupping it. And I got my margins in here for the chain ring and the crank arms. So what I would do now is I'd say, that gives me all my margins. I'd come in here and I would go, I don't need all that material, and I don't need anything from there forward, right? And of course I do it on this side and do the same thing. And you'd want to have them more or less symmetric. They don't have to be symmetric though. That's the key thing, is it's your design. And you can make your bike symmetric, asymmetric, whatever you want. And just so you know, a lot of bikes have asymmetric chainstays. It's done for multiple reasons. Some are actually structural reasons, some are clearance reasons, and others are just for aesthetics. Anyway, oh yeah, and you can you can do like a solid chainstay here, partial, and then weld the aft part of your chainstay on by cutting it and doing different things. All kinds of ways you can do your chainstays. But hey, let's get back to so once you have it marked, you can go and cut the excess off, and now you can go and also get the angle correct for your dropout. Damn it. So let's say this was the dropout that goes on. You can then set that angle, and you can now chamfer your chainstay that fit the dropout. Okay. And that way you can actually start your welding. You can weld this on to your chainstay in advance of actually doing anything else before you do the mitering on the forward end that mates up to your bottom bracket, bottom shell. I don't know why I keep saying bottom bracket, but anyway, so you do that, and once I have these all marked out, now I can transfer them to my chainstay jig, and I'll show you what that looks like. So as you can tell, I kind of have a thing for 80/20 extruded aluminum. Maybe it's because it's easier and it's fairly inexpensive. But all I've done is I've taken an 1.5 inch 80/20 aluminum extrusion that has the channels that run down the center, and then I've taken some plate. Well, I don't even know how thick that is. Let's do a quick measurement. 1/2 inch plate, and some attachment threadwear. I put a pin on this one, like this. Okay. What you need to do is make sure that it's centered, that it has equal distance, because this is going to hold your chainstay drop areas. All right, and so give you an idea real quick. There's a clamp here and a clamp here. You can see I have 148 millimeters checked out here. And that tells me that's where the end of the chainstay needs to be. And then at the other end, where it's slotted, it's going to allow me to have a V clamp to move it in and out. And it looks like something like this. And they have hardware underneath that allow me to clamp them. Bolt comes up through the bottom and they rotate so I can set the angle and then tie it down. Okay, then on the chainstay side, I have these little sliders that I made that I can then clamp it down back here, and it holds the chainstay in, comes to drop in place, and then a plate will come down over the V and it holds these in place so I can do my miter with my mill. And that's more or less how it's done. Now I was going to go ahead and make some new V blocks here. I've never liked them. They don't fit that well with mine. But I've just been too lazy to do it. And hey, you know, I've been doing this whole thing showing everyone how I do my stuff. So this might be a good time for me to go ahead and just update these V clamps maybe. We'll see. I'm kind of tired. I've been doing a lot of work. I've been working on a trailer conversion for my wife and I, and so that's been kind of taking my all my time, along with a few other family type things. But it's been a lot of fun, but it's slow going, so I may not want to do this. Not yet again. All right, hang tight. All right, so let's go take this over to the mill and we'll cut the chainstays common to the bottom bracket. So you don't want to forget to put your breather holes in your bottom bracket either. And so you can see I've traced basically where those would go. And now I'm just going to put the chainstay up there and check for clearance with that clearance tool that I have that's attached to my jig. And there you can see that that's what I'd be looking for. And if I have it touching, I have about 15 thousandths to 30 thousandths of clearance between a 32 chain ring. Normally I would have drilled these holes prior to doing any of the welding, but I forgot. So here we go, I'm doing it manually. Now I'm just doing a fit check with the chainstays and positioning them up against the bottom bracket all the way back to the dummy axle, and with the block I'm checking for my wheel clearance. 29er location wheel. So I got plenty of clearance. And chain ring, 32 chain ring, won't strike the actual chain stay. That's what this is to do. So if I butt it up against this as a stop, I still have about 3 millimeters of clearance. So it's a good, I will back off just from that to give myself an additional 2 or so millimeters. So 5 millimeter clearance, not bad. But checking for clearances, right? And then again, go back in and check for total wheel clearance. So that's over 2.5. So I can get at least a 2.4 tire on there, no problem. What we're looking at here is $29 right there. So it gets to right where the chain ring would actually end. It's just to verify my clearance again, right? So quite a bit of room. Probably get a 2.5 on there with no problem. And then the chain stay length is going to be 17 inches almost on the nose. All right. Good measurements. So now all I have to do is prep the ends just by cleaning up and doing an acetone wash, and then I can actually weld. Okay, I'm just going to tack the chain stays in place here, and I'm going to start with the non-drag side, which would be the left-hand side. And I'm going to start at the bottom bracket and just get that tacked in, and then I'll tack the drive side in. So what I'm going to do is tack bottom and top, or in this case, top and bottom. And okay, so let's do a test here and see if I got my clearance. Yep, I get in there. back to the bottom bracket. Now we just need to go and do it at the drops. Okay, so I got my chainstay and drops all welded up, and I thought I'd throw a my 27.5 back wheel on there as a check, and you can see what it looks like. It's not a 29er, but I didn't need to have a 29er just to see the alignment. And I'm actually kind of pleased. I had to do a modification on the fly and had to cut the drive side dropout off and re-weld it on. I don't know what happened, but for some reason it was a little off. So, you know, you can make these on the fly corrections if you have to, as long as you're checking fairly regularly to make sure that something didn't go horribly wrong. And that's what I did. Is I noticed that the rear wheel was coming in slightly off. So my jig must be still off a little bit, and I'll have to troubleshoot that some more. But here you go. So this is my 27.5 Evil Insurgent back wheel that I put on here just as a go no go check picture, you might say. And there's you kind of see my clearances are pretty good, not too bad. I believe this is the 2.5 on the back wheel. Oh, it's a 2.4. So I got plenty of room. Definitely can squeeze a 2.5 on there. 29er might be a little tighter, but I think it works just fine. Okay, and here's a look at the back. Lines up with the seat tube, head tube, and you can see that's what I'm looking for is to make sure that everything lines up with each other. Ground clamp is in the way, but it actually looks pretty good. I'm liking it. Looks pretty right now. Any type of small variations, like if I get this lined up really straight on, but if you were to see it from my angle, you would see that the wheel is maybe slightly pulled that way, just a smidge, but that can be adjusted when you put your seat stays on by preloading it just a little bit, and it will cause the wheel to deflect one way or the other, and that's how you can get it just perfectly dialed in if you find that it's slightly off. All right, so we got to work on the seat stays next.